Alright, post me here. I'm literally editing the video right now and I just started doing it, and for some reason I realized the audio from my microphone is really terrible for this video. I don't know why. It is obviously fixed right now. I don't know if the cable was loose or whatnot, but I apologize for the audio quality of this video. I apologize for a lot of things in this video. This one just kind of turned out to be a disaster, but at any rate, I just wanted to say that to you guys, and let's get into the video. Alrighty, welcome everyone to day 11 of Advent Decode. Yesterday's question, the part 2 at least, it's starting difficult. These questions are starting to ramp up. I fully suspect that kind of starting today and going on, these questions are going to be sort of pretty difficult. They're at the point where I think some of these might take me a while to solve, or I might not be able to solve them. But anyway, I'm going to keep going with these, just keep going as long as I can. I think last year I got to like day 18 and whatnot, but at any rate, question will be released. I got my base code already. Day 11, let's go. Your plane lands with plenty of time to spare. The final leg of your journey is a ferry that goes directly to the tropical island where you can finally start your vacation. As you reach the waiting area to board the ferry, you realize that you're so early nobody else has even arrived yet. By modeling the process people use to choose or abandon their seat in the waiting area, you're pretty sure that you predict the best place to sit. You make a quick map of the seat layouts, puzzle inputs. The seat layout fits neatly on the grid. Each position on the floor at dawn is an empty seat, L is an occupied seat. Oh, wait. Each position on is either floor, empty seat, L, or occupied seat. Okay. For example, the initial seat may look like this. Cool. Now you just need to model the people who will be arriving shortly. Most people are entirely predictable and always follow a simple set of rules. All destinations are based upon the number of occupied seats adjacent to a given seat. The following rules apply to every seat simultaneously. If the seat is empty, there are no occupied seats adjacent to it. The seat becomes occupied, the seat is occupied, and 4 more adjacent seats to it are also occupied, the seat becomes empty. Okay, floor never changes. After a second round, the seat with 4 more becomes empty again. The process continues with 3 more rounds. The case stabilizes, and further application of the rules causes no seat to change state. Okay, so it's like okay, I sort of going here. You count 37 occupied seats. How many seats end occupied? Okay. Wow, that's a lot. Okay, so what we're first going to need to do is not that. What we're first going to need to do is dump this into our day 11 inputs. This will be interesting. So we have basically this entire map here. Yeah, okay, so it might be a 2D array might be the best option. So the rules, the following rules are applied to every seat simultaneously. Okay, if a seat is empty and there are no occupied seats adjacent to it, okay. So what we need to do is we need to build this map. And essentially what we're going to do is to apply these simultaneously. We're going to have our map of our current state and a map of our next state. That way as we go to each seat, we can look at each seat, apply the rules as the moment, and then mirror those, what the outcome comes to be onto our new state. So first, let's just load these into, I'm going to load this actually into a char map, a 2D char array. I didn't mean to do up here. And this is going to be seats, and we're going to do a new char array, and it's going to be the x, which is input strings get 0 dots. Actually, what I can just do 4. Whoops, I need to keep this. Oh, we need to do, okay, specify, and then this is going to be to char array length, and then this is going to be then input strings dot size. I think that's right. Maybe we're gonna do this way. So anyway, so then we're gonna fill these in. We're going to do a for int I equals. Nope, these are flipped around. My bad. For int I equals 0, while I is less than input strings dot size I plus plus. And what we're gonna do is we're going to head and go do is seats. I messed one of those brackets. We're going to do seats, and we're going to set I equal to input strings get 0 dot to char array. Cool, and so that'll build up our nice little seats array here, make our life a little bit easier. I'm gonna do that. So now what we need to do is we need to basically apply all these rules simultaneously. And we need to keep doing this over and over again. So what we're gonna do is a method here. It's going to be a public char map, and we're going to we're just going to call like an act method or an update method. Sure. And it's going to take in a char array and go this way. So this is going to apply our kind of updates here. So we're going to first have to make a new char array here, updated, and it's going to be seats 0 seats dots length, and then seats 0 dot length. I think that's how this works. Been a while since I've done 2D reads like this. Okay, and so what we're going to do is we're going to go for, we're going to make basically a double for loop here. I'm just going to be lazy and copy this. So int I and j. Okay, and this is going to be updated length, and then updated I length, sure. Okay, and so now what we need to do is we need to now run our rules. So, for update, so what we're going to have to do is we're going to have to first get the char, so the seats, or excuse me, the char at is going to be seats, and it's going to be I, j, and cool, and so that was our char. So now we need a cool, nice little switch statement on this char at, and our case, our first case is if it's a floor, we do nothing. Actually, we can just make the default to this, so the default can just be that, so we're not doing anything. So we can do a case here for the first one, which is an L, which is an empty seat, and then break, and then we're going to do a case here for the last seat, which is a pound, which is occupied, and then break as well. So now for the rules. So for if it's an empty seat, if the seat is empty and there are no occupied seats adjacent to it, the seat becomes occupied. Does this mean adjacent as in 4 directions? 1 of 8 position to be the up, down, left, right, or diagonal. Okay, so we got to go all the way around. So we need to test if there are any occupied seats around it. So what we need to do is we do a quick for loop for int. I guess we can just do. Now we'll do it this way: for int I off is going to be equal to -1. We're going to do this way: equals -1. Well, I off, I misspelled I off, is less than 2 I off plus plus. Basically, we're just going to go around and check each one by going through each of the 3 rows and each of the 3 columns, doing it this way. So there's I off and there's J off. Okay, we do first need to check if I off equals 0 and J off equals 0. We don't care about this one because this is where we're at, so we want to just simply ignore this one. So just do a continue real quick. Okay, so now what we need to do is we need to check if this is occupied. So this is basically for changing to occupied. So here and oh wait, it's gonna be starting off to occupied. Okay. And then what we're going to do here is we're going to simply check if the char at here, so we're going to get the char at off, call it, and we're going to check if it's going to be seats that plus I off plus J off, and then we're going to get our seats there, and we're going to check if the char at here is not occupied, which is a floor, or it is a non-floor, so an L, and those are all the unoccupied. In which case, it stays occupied. So we only care if it is occupied. So we only care if it is that, because then we set occupied to false. And we can break out of this for loop, and then we can say if it is not occupied, also break here. And then we get to here. If we are setting this to occupied, go ahead and adjust updated. Actually, we can do it either way. We can just do updated at I and j is going to be equal to occupied. If it's occupied, the pound symbol. If it's not occupied, it's going to be the L symbol. Right? Yes. Cool. There, we can also just do in the default, this is a floor. Floor stays a floor, so we don't need to do anything here. We can just simply set that as a floor. Alright, so there we go. So now there is the L's done. So now we need to do is we need to check the other state, which is the occupied. So if a seat is occupied and 4 or more seats adjacent to it are also occupied, the seat becomes empty. Okay, so we're going to do the exact same thing, except instead of occupied, we're going to track int occupied count, and it's going to be 0. Don't care about this now, so we're going to do the same thing, but all we want to check is if it's occupied. Now we want to just increment occupied count, and when we get to here, we're going to do occupied count is greater than or equal to 4. It becomes empty. So the opposite way is to become empty, otherwise it stays occupied. Okay. And there we go. So now we have the rules that will work and apply for this. So what we can do is we can just call, let me do this, change this to seats. I'm just curious, I just want to see what this looks like. So actually we're going to change this to updated, and we're going to set updated equal to update, giving it seats. Okay. And I just want to output this to the screen, system out print, just to verify this is working. Let's output updated I, updated j, and here run a print line with nothing in it, and there we go. Yeah, okay, it's fine. Alright, so we're good. What's the only thing left here? Oh, we're not returning updated. Last thing we need to do is in this loop we need to return updated. There we go. Okay, let me run this. What we should get is after this first run, we should see everything being occupied. Once Java decides to load here and run. Come on. You can do Java. If I run the right day. Okay, now if I run the right day, we should see every seat being occupied, unless we get index out of bounds exception, which is -1. Or I off minus, or I minus I off is less than 0, or plus, or same thing with j and j off. I guess there's technically a greater than as well. We also need the ors for I and I off is going to be greater than updated.length, updated 0, I. Whoops. There. Okay, so now if we run this, now we should get this right. So now I shouldn't check all these. Equal, sorry, not greater than, or less than, equal. Cool, and we see is everything is occupied. It's actually, that's not what our... That's not right. That's not what our input looked like. Okay, let's do this exact same thing, but instead of doing it here, let me do it right here. Or, sorry, let me do it right here. Instead of doing it on here, let me do it for seats. Something ain't right here. Ah, because I'm not getting I. There, that looks more like it. Okay, and then now if I run this, now I run this. That's why we verified, chat. There we go. Much better. Okay, so now we need to kind of keep running this until seats and updated are the same. So we're going to do while our boolean same is false. So we're going to do a while not same. We are going to run this. So it's going to run once and then it's going to check. What we can do is we can just have updates be out there. There, and we just do this as seats. Okay, there we go. So while they're not the same, we're going to do this, and what we're going to do here is we're going to check. Oh, but this is going to be, we need to do it differently. We need to do updated. We need a different char right here. This is just going to be temp. Okay, so what we need to do here is we need to go through each of these, and we need to basically every run we're going to set same to true, and we're going to have to run through and check if temp I and j does not equal updated I and updated j. We know they are different, in which case we set same to false. Cool, and then we can just simply, we can make a break here to break out of this, save ourselves some runtime, and then also make a check here if not same, also break. Okay, and then we do this. Now what we can do is at the very end of this, once we roll out of here, we need to now count down occupied, so int occupied equals 0, and all we need to do here is we have updated. So now we just need to check that updated equals this. Now we get the number updated. Whoops. Now we have an updated seat, and we just simply up this by 1. And now we can just do lap and occupied. Good? Sure. Fine. Okay, run this. What do we get? Brain extended bounds exception. How? Oh, because you don't check it here. Right, you don't check. Run this again. We get this as our answer. Ran pretty quickly. I'm gonna be pretty happy with that if it's right. Hey, we got it right. Cool. And again, this one wasn't too bad, but it was a lot of work to get to that point. Okay, part 2. As soon as people start to arrive, you realize their mistake. People don't just care about adjacencies, they care about the first seat they can see in each of those 8 directions. Oh boy. Now instead of just considering the 8 immediate adjacent seats, consider the first seat in each of the 8 directions. For example, the empty seat below would see 8 occupied seats. Oh, that's annoying. The leftmost empty seat below would see only 1 empty seat. We're going to see the occupied seats. Okay, so it's also in each direction. 5 more visible occupied seats. Okay. How many seats end up occupied? Alright. So it takes 5 or more rather than 4. That will still apply. Okay. So. Okay, quick interruption again. Again, I'm editing the video. You'll notice there's going to be a big cut here from when I finish reading the part 2 kind of problem and then when I actually solve it. It gets explained later on, but basically I messed up. I misread the part 2 requirements and I spent a long time doing something that didn't work because I misread. So I'm going to skip here to when I started solving it after I realized I misread it, and it's going to be the solution from here on. It made more sense to do this because they were kind of separate and kind of redid all my code anyways. But if you are curious, my failure to solve this will be included at the end of it. And again, I'll explain this more as I get to it. So anyways, back to the video. I'm actually having a problem. Wait, so in this problem here, we get to say this one here. Why does this one change? Because it says it's now unoccupied, but it only has 1, 2, 3 occupied seats around it. Why did that one change? Wait, I don't get why that one changed. Is it also in, wait, is it in every direction? It's in every direction. Oh my goodness, I just totally... It's in every direction. Okay. Every direction. I have to redo this. Hold on. That's a huge not plot point, but it's a huge point that I just totally missed. So I'm going to actually redo all this, because this code got run away anyways, and I just missed a huge point, which is that it's in any direction. So what we're going to do is we're going to use what we did up here actually. Is this going to work? Yes. We can reuse what we had above and adjust it slightly, because it's every direction. We can have... sorry, not end up there. We have an internal here, because this is only going to change it by a direction of 1. So what we do is if we go to here... we do need to do this check. We need to run this check first. But assuming that this runs, assuming that that passes, what we can do is we can do this second for loop inside of it, and we can have this one extend out, kind of be like a scalar. So call it scale 0 while scale is less than 100. I don't know. That part I don't know right now. We can just do scale plus plus. And what we can do is we can put all this inside of here to start the scale at 1. We almost got to start the scale at 1. So we're going to do the I-offs, but we're going to then multiply them by the scale. So now we're actually doing... we're going to do int I-off scale. It's going to be, whoops, this. And so we can place all the I-offs with I-off scale. And then likewise, all the J-offs with J-off scale. And this should make our solution much, much better. Or not much better, but this should basically be the exact same thing, just switched up. So, same part here, we want to go until we find, in this case we want to go until we find the first one of these. So we need occupied, but we also need another flag here, which is going to be, it's going to be boolean complete. That's how we know we're done with this direction. So we need an else if here for an empty seat. We have found it. It's not occupied, but we can break out of this loop. Which means we're done with this loop, which means we go out to here and we can change up our scale. Okay. In this case, it's only one occupied that breaks this, right? Yes. So that. Okay. And that should do this part just fine. So now on to the second part, which is this. We're going to do kind of the exact same thing. All right, we're going to move all this terrible code. Okay, we're going to do basically kind of the exact same thing we just did here. I'm going to remove that other bit, remove this. Okay, we have the 4, we can do this. I can just copy the whole thing, because the only thing that's different here is it's now just going to occupied count plus plus. So now this is going to be occupied count plus plus, same thing for here. Cool. There we go. So now this should be what we're looking for. Fingers crossed. Let me do this again. It should stop relatively quickly. 26. There we go. I think we got it. Okay. I don't want to talk about it yet. I don't want to talk about my first attempt at part 2. Let's just ignore that happened. Let me remove this. I don't want to talk about it. Please tell me this is the right answer. Oh, okay. I will say this question wasn't that bad. I just made it a lot worse because I messed up and misread the question. How bad did I do on the leaderboard here? Look how I tanked. I actually tanked it just because I did the first one pretty good, but then I tanked the second one because I had to misread. Okay, so think about it right now. So what I'm gonna do is it's gonna be a really weird edit. So what I'm gonna do is I'm going to cut out that entire first kind of misstep there. I'm gonna cut it out. I'm gonna move it to the end of the video because I feel like it's good to know how I kind of what I did, but at the same time that first try is not really relevant to anyone just because I messed up. So I guess at this point now, you're at this part of the video, you haven't seen me mess up my code. So after I explain my code here, I'm gonna put at the end here my initial try where I messed up and I misread the question. I thought that only the four cardinal directions went infinitely, but instead all 8 directions extended that infinite scale and whatnot. So of course I spent a lot of time trying to kind of get that around, and I was like, it's working. Why is my code working but things are wrong? And then I figured that out. So at any rate, so that was my solution for part 2. That was the working solution after I figured that out. I'm gonna go ahead and explain my code here, and then after it I'm going to include the code where I messed up and went about that. So at any rate, for this problem, so we're basically given a big kind of array or a big input of seating arrangements and possible seats in a map. There are rules to where if it's an empty seat, it changes to an occupied seat if there are no occupied seats around it. Basically, I won't go over all the rules, but just know that all the rules apply instantaneously. So what we have to do is when we first go up to the top here, when we first read all these seats into a char array, we have to make a copy of this and then send this off to apply these rules, but then we need to check it against what we got because the rules apply instantaneously. So if we go to part 1 here, we make this kind of copy here where we go through all of them, we do the check for the rules at this location. So in this case, here's a check for an unoccupied seat. We check here if it gets switched to occupied, at which case if it does, we update the new array, not the current one. That way all the rules are applying at that specific moment with no other changes taking effect. So just know that those are the rules. So we kind of apply the first rule, the second rule here. I'm not going to explain this too much because it's a little bit hard for me to explain. Just know that we're applying the rules, we're checking each seat and applying them there. What we do then is we come back up to our main kind of loop here, and what we're doing is here is we're applying these rules, we're getting the array back, and then we're checking that array against what we sent in. If the arrays are identical, we know we have hit a kind of a stagnant point where there are no changes being made, so no changes will ever be made, and now we're just what we're going to do is we just stop our loop there, we count up how many seats are occupied, and that's our solution. Part 2 is the same way, but instead of only checking the direct adjacent seats, we're checking the direct adjacent seats and then extend it out for infinite, basically arrays going out. So same code, but the only thing we change is that our check for loops here are checking around around our location, but they're only checking in a radius of 1. And so the way we extend that out to infinity is we take that radius of 1 that we're applying and we just add a scalar. That scalar starts at 1, but then goes to 2, 3, 4. That way we basically kind of keep growing our check space as we go out and still apply the rules that I had before. So a little hard for me to explain. This is kind of, we're getting to the parts where it's a little harder for me to explain in great detail. I guess I try to explain to newer people who are programming, but of course these questions are pretty difficult. So hopefully if you kind of are more knowledgeable in programming, you kind of understand my code as I went and wrote it. But anyway, okay, I'm getting a little long. This video is going on. Just okay. Any rates, I'm gonna call it there. We got part 1 and 2. That's all for me. Hope you guys enjoy it. So next time, if you care enough, you can stick around. You can see me fail miserably at my first attempt to part 2. But if you don't, thank you guys for watching. I'll see you guys all tomorrow for day 12. Peace out. What we need to do now is we need to adjust this. So this is going to be update part 1, I'm going to call this. So we're going to keep these as they are. We're going to have a different one for each of the parts, just so that way my code is there for both parts so you guys can still see it. Okay, so now for update in part 2, we're going to copy this. This is going to be update part 1. Okay. Alright. So for update part 2, it's going to be the same, so we still need to have this, but now this is going to be a 5. But now what we need to do is we need to also run all of the cardinal directions out infinitely. So, so we have these now. So what we can do is after these, we're going to quickly do an if occupied. We're just going to quickly do this real quick. Then I can break out of this. Otherwise, we're going to still do what we just did, but now we're going to extend this off in the cardinal direction. So, equals 0. We're going to basically have this offset apply to every direction. So I is equals 0, while I is less than. I don't know. I don't know. We're just gonna make it 100. Just, I could make this a real number, but I'm just making it 100 just because it's easier for me. Just to have a number here. Okay. So for each of this, we already have an I. We already have an I. I'm gonna call this A, just as an A. Okay. So now we're going to go off in each direction, and for this, we're gonna do is just check. We have the offsets there, so we're going to have to check that A is going to start at 1 because we don't. Actually, A is going to start at 2 because we don't want to check where we're at, and we don't check the ones around it because we already checked those. So we're going to have to check these. So we're going to check I plus A, or I minus A, J minus A. Okay. So these are going to be run individually for the if statements. So the first one is going to be if is greater than 0, we need to check here. So we need to do a quick check char at, this is I plus A and J, and we need to check only here. So if it is occupied in this case, right? Yes. If it is occupied, we care now. So they need to be able to see. Wait. Here, about the first seed, they can see in each of those 8 directions. Okay. So we can do this, but we need to know. Oh no. No, this is not gonna work. This is not. This is not the. It's gonna work, but it's not the right way to do this. Okay. Okay, I need to think about this for a second here. So I'm gonna quick do a cut after I do some thinking, and I'll catch you back there. Okay, so what I'm gonna do is I'm gonna keep doing what I'm doing here, but this has become our main sort of loop. So I don't need this anymore. So I'm gonna just remove these. I'm gonna kind of do this from scratch again. So this is going to be, we're going to basically extend this out infinitely, and we need to know each of the directions. So we're gonna, this is gonna be kind of rough. We're gonna keep track of each direction. So north, false, east, south, and west. So this is what's going to control how these are going, or these are going to control. Yeah, these are going to control how it knows which way to go. So north, east, south, and west. Okay, so I minus A, this is going this way, so this is going west, and west. So, and we will continue west, so these are all going to start as true. And what we want to do is we're going to extend out, and we need to see the first seed they can see. So either it is an empty seed or it is a adjacent, so we don't care about the floor tiles. So, in this case, and west, what we care about here is if the seat here, so this is going to be char seats at, it's going to be that. So we care if they see is an occupied seat. In this case, occupied is going to be set to false, and we can break out of this. We are done with this loop. Stop here. Actually, we don't need the directions because we only care. We only care if any of these. So we actually don't need these directions for this one. We will for the next one. So I'm actually going to copy these and move them over down to here real quick. Because we will care for this. For this one, we don't care. We want to make sure that we don't find any seats. But we do care if it is an empty seat. Hang on. Sorry, I messed this up. I was right. We do need these here. Anyway, so if it's this, we're occupied, we break, we're done. Otherwise, if it is an empty seat, occupied is false. We don't break out of this, but we just set west to false. We don't want to continue looking at the west direction because we've already verified that they see an empty seat. Cool, so what we're going to do is we're going to copy this a few times. So west, and this is going to be north. This is J. Right? Maybe not. I might not be what I think it is. Nope, I is the column. I is this way. Okay. So this needs to be, well, that's still I minus A, but this is the wrong way. This isn't west, this is I minus A, this is north. West, okay. So then the opposite way of J minus I, now this is west. So this is me J minus A. K, if it's there, then west is false, good. Okay, and now when you get into the I plus A, going for this. This is south. I plus a, k. This is probably not the best way to do this, but this is what I'm going with. I've just kind of committed to this, and it's kind of an whatever scenario. This is probably a lot of duplicate code, but I'm just committed. So south and then east. Okay, and then updated 0 and j. Okay, so that should cover for this, and again we get to here, we do this. Okay, so now for the unoccupied, same thing, but now we don't want to stop, or we do want to stop. Oh, I'm also forgetting, before I forget, I'm forgetting the other checks. If not occupied, we're forgetting the four corners. So we only care about, in this case we only care about this, so we're just going to try I minus 1, j minus 1, whoops. Okay, if the CDAT is that, we set occupied to true. And this is going to just simply check each of the four directions, or each of the four corners around this. CDAT, 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 so I plus, 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 plus. Cool, alright, so that's good there. So now we want to do the same exact thing. I'm going to be bold here and copy this code. It's a bold move, but I'm going to be bold. Okay, so this time all we're doing is doing the same exact thing. Right, I forgot you can't use cases. Java's a little annoying. You can do the cases here, but I can bump these outside the switch statement. Okay, sorry, I bump those out. So occupied count there. So what we don't want is we don't set occupied. Occupied is irrelevant here. Instead, we want to set is we want to do. If we see either of these, we set north to false, but we want to then set occupied plus plus, or occupied count, sorry, occupied count plus plus. Cool. This is west. No breaks, right? No break. Set it, but don't break. This is south, and then this is east. Okay. So that'll stop them from going in the directions, but it won't stop from that. Okay. And then what we want to do is we also want to do checks here, and instead of this, we're going to do occupied count plus plus. Again, same reasoning. And then let's hope that this works for part 2. Okay, very annoying, but we're going to take this. And we're going to apply this to part 2. Yeah, I'm not very happy with this code, but this is just kind of how I've had to go with this. And we need to run the part 2 code. Wherever updates part 2. YOLO, let's see what happens. We're gonna accept the bounds exception. I plus A. These are all flipped around. Less than. This needs to be less than. Nope. That needs to be less than. Yeah, I forgot to flip those around, so it's also true down here. I flipped the top ones, but I didn't flip these ones. Okay, run this now. We can answer. Oh, we need checks here. Okay. Yeah, I got these bold checks now. It's going to move all of these to be also including this. Okay. Is less than seats dot length. Okay. Oh no, this code is really, it's run away. This code is run away. Yeah, I would not take what I'm doing as gospel at all. This code is definitely runaway code badly. Badly runaway code. Less than. These are all greater than or equal to, aren't they? Shoot, greater than or equal to seats I. This is bad. Runaway code. Okay, and there's going to be the same true up here. It is going to be the same as true. Well, what I can do is I can copy paste this real quick. I'm going to be lazy and bad. Copy paste this, but we're just checking, and we're setting it to be that. Okay. Run this. Still here? What? Oh, because that's I minus 1 is greater than or equal to 0. I missed 1. So that's going to be true up here. I missed this bottom one. I minus 1 is greater than or equal to 0. Yeah, this has just gotten really run away. I'm really unhappy with this. This might take a second, though. I didn't think it'd take a second. Unless I did something wrong. Give this certainly above. Okay, let me copy this as my starting input. Yeah, it's not going too well. Okay. Does this work? Ah, so this doesn't work. Oh, build complete. Wait, it ran. Oh, it's still running. Okay, so I have some sort of infinite loop somewhere that's not going right. Okay. Great. Fantastic. So temp, so we're going to update it to seats. Updated there. Yeah, we have a runaway somewhere. If I run this, it's just going to keep saying here, here. Yeah, okay, so somewhere this isn't running correctly. Okay, we're going to run this once. And instead of we're going to still do occupy, but we're going to do a system out print of HR and system out print line. Just so I can kind of get a visual on what's happening here. Oh, it's in the wrong place, isn't it? Of course it is. Of course this is. Sorry, this should be on down here on part 2. Run this once. And system out print line, nothing. Oh, this needs to print out regardless. Alright, what do we get? So after the first iteration of this, part 2. Huh? Alright, this is what we get. Which is not right. That is not what we should get on part 2. Oh no, chat. And this is gonna be something I have no idea how I want to update this. Like, I don't know where to debug this at. So obviously they're all being set, which I keep opening the wrong things up. So they all get set, which is right, but then they should change. Okay, so wait, no, the first iteration's okay. Okay, so the first iteration might be okay. Okay, so let's copy this. And debugging time begins. So update, which is fine. I don't care about that. I just want to output here. And then a few system out print lines. Okay. Run this for a second. Okay. I'm going to stop it. Oh, I stopped it perfectly. So as you can see here, that does not match up to this at all. That does not match up that at all. Well, this is wrong. Was that it the whole time? Alright, still infinite looping. Let me run this quickly and stop it. Nope, that did not help at all. Well, part 2 might be a struggle here, guys. I'm going to do some more debugging, and I'll try and catch you guys at the cut here, so that this video doesn't get too long.